Good morning and welcome to today's webinar presented by Industry Week and Smart Industry titled Breaking the MES Mold, New Strategies for Manufacturing, sponsored by Tulip. My name is Dennis Semeka, Senior Editor for Technology at Industry Week. I would now like to welcome our speakers. Jessica Yen, Global Customer Success Lead at Tulip, is passionate about manufacturing and using digital tools to help manufacturing companies drive measurable impact and cultural transformation. Jessica leads the adoption management and customer services teams. Joining Jessica today, we have Brian McGarvey, Global Account Manager at Tulip. In his role, Brian partners with customer stakeholders to enable adoption of Tulip at enterprise scale, maximize value creation from the Tulip platform, and ensure overall customer success. Stanley Black Decker is one of his main customers. Welcome to you both. The floor is yours.
Thank you, Dennis. Great to be here. Brian and I actually did a webinar with Industry Week last year, so I think we're excited to return again with a different topic. So I'm going to jump over to the agenda and walk you through what you can expect to hear today. We're going to start out with some higher level trends and themes around what's going on in the MES, so manufacturing execution systems industry, and what's disrupting it. We'll then focus on a specific bit of concept called composability. It's a different design principle for manufacturing systems. So we'll get into that, and then we'll show you an example of composability in practice based on some of our real customers and how they've applied this to make their digital transformation successful. And then we'll wrap up with some summary of trends and what are some future webinars you can look forward to are. Before we get into the first section, we are going to start with a poll, which is about, we want to understand how well your MES is working if you have one today. The options are great, which is you have access to the data you need when you need it. Your operator is entering data, can use it pretty easily. Okay, we can operate it, but not always efficiently or effectively. Third option is not great. It's maybe causing some barriers to your operations, inefficient, can't get all the data when you need it. Fourth one is terrible in that you get frustrated with it on a daily basis, or maybe your end users, different managers, different people who have to interact with it are frustrated. And the last one is you may not have a formal manufacturing execution system. You might be doing things on paper, some of it in Excel. Maybe you have some other solution that covers some of what you think an MES should be doing. So about 40% of folks currently don't have an MES. That's a great reason to come to this and understand more about how to think about MESs and concepts within that. And then a lot of folks are in we have an MES, it works not great. So you've got something, you have some data in there, but there's probably frustrations with it. That's actually looking like almost a tie between either not having one or you have one and it's not great. So thank you for participating. That is helpful benchmarking for our conversation. I think with that, I'll turn it over to Brian.
Awesome. Yeah, thanks, Jessica. Just for all the people who are kind of in that middle bucket, even the end, like know that you're not alone. Like that's usually a pretty common starting point for customers we start working with. So really excited to get into this section, again, as titled MES Disruption. So kind of our point of view and what we're hearing from others as well for how this market is really shifting and new technologies that are kind of emerging. And we'll, again, as Jess mentioned, one of these key things will be composability, and she'll dive into that in her section. So our point of view and what we've seen and what we've heard from industry experts is the frontline operations software market is fundamentally changing, kind of across four dimensions: cloud, composability, connected, and cognitive. So cloud, obviously, over the last decade, maybe 2 decades, the shift in manufacturing to cloud has typically been pretty slow. But now, this concept of multi-tenant SaaS is most manufacturers becoming more comfortable with the concept, the reliability of that, and that it's a go-to deployment for most people when they really look into the details. Composability, as I just mentioned again, like Jess will do deep dive here, but composable approaches, the way that you design systems, thinking about humans first and the operator needs. Those approaches are replacing those monolithic systems and the monolithic MES that has traditionally dominated the market. And again, not surprising that based on our poll, like what we see is like that's not been a good fit for a lot of people that have kind of gone down that path. The third pillar there is connected. So IoT, those machines, sensors, smart tools. We're not saying that being able to connect to your machine, sensor, smart tools, and others is something that's new, but the ability to do that in a democratized way, that the rapid change of pace and being able to have access to that is something that is accelerating the market, as well as, the concept on the IT side of both, doing on-prem as well as cloud and, more cloud-hosted APIs, and being able to do hybrid. So being able to connect in multiple different ways and kind of meet your manufacturing needs where they are, and then cognitive. So everyone's favorite buzzwords of the last 2 years, machine learning, generative AI. But it's really exciting to see, not only at Tulip but also competitors and peers and partners, is the acceleration of enabling access to meaningful ML and Gen AI type solutions, and where that's actually going to go in the next couple of years to make that accessible to people on the shop floor to actually move the needle in your operations. So, there's a new digitally native operator workforce out there. So the point of this is the needs of the people that are entering the workforce and that are in the workforce are fundamentally changing. Their expectations for how they work is very different than 25 years ago. And based on CFO magazine from a few months ago, 70% of Gen Z employees would switch their jobs for better technology. And then on Gen X side, it's near 50%. That's a significant amount of the workforce, especially white collar workforce, that would shift to jobs for better tech. So think about your engineers, your IT, those people will pack up and leave if you don't keep pace with the tools that they need and that they expect to have in their jobs. And so from a technical employee perspective, process engineers want to be able to improve operations. MES engineers want to capture and analyze data. Supervisors responsible for hitting the performance goals, qualities, escape rates, and others. And IT is connecting systems to protected data. All these people need those tools to do their job correctly, and they have it everywhere else in their life. But typically, in a manufacturing setting, it's typically been lagging. So fundamentally, that expectation is shifting. And then also just kind of at a macro level, manufacturing resilience and adaptability is no longer nice to have. You obviously have customer demands, growing complexity. So that's kind of on both sides of the spectrum, personalization and customization of products, depending on the market, obviously, and what your company does, but also the shortened cycles for technologies and new technologies being infused into products. And then obviously, for the last, it feels like we've been talking about this forever around supply chain disruptions. It still is happening today, especially in the post-COVID world, but it seems like there's always a new headline. I mean, whether it's, something around just the industry you're in and where, sourcing raw materials, EV and raw materials, but also disrupted supply chains and trade wars and actual wars and in conflicts. I mean, just reading an article in the New York Times yesterday about all the shipping traffic that is being diverted from the Red Sea around, South Africa, and that's actually impacting. And so those types of things are very real and tangible. I'm sure many people in this audience are feeling that today in their operations. And so this isn't going away.
Well, something we talk about a lot is there's so much technology that serves so many other industries. I know we've talked about supply chain tends to be a heavy analytics industry, and there's a lot of software that serves that. We are very excited to bring better technology to manufacturing because if anything, this should be an area that's full of the newest technology, the best stuff, including on the software side.
Yeah, thanks. And I think it's goes really well into this next concept here is the fact is today, the majority of today's frontline manufacturing systems aren't human focused and they don't adapt well. They're not agile. They don't meet the needs of the people using them or the processes in which they're supposed to serve. And so time and time again, walk into, as they're starting their journey with us or, in a previous life in consulting, seeing any one of these three, whether it's paper processes dominating the shop floor, or they implemented a point solution, or they actually have a legacy MES solution, but the team that implemented or the guy who knows how to actually run it has retired or is out for 2 months. And it's not to even make a change to that requires, lifting a boulder. Or sometimes there's all three of these, right? There's a mix of paper processes, there's a mix of point solution, and they have this legacy MES in this one part of the shop floor, but all of the data is never connected. It is a hurdle to even get insights out of, at best, paper processes that might end up in Excel and, very time consuming to actually put that in Excel, but that's not flowing nicely into any legacy MES system you have or other. And then point solutions tend to be historically been much more narrow and focused in serving a single need. Again, I could tell stories on how we've seen kind of this implementation. Jessica, I'm not sure if you have want to add any insight there.
We get a lot of stories. One thing, I think this is a good place to point out, though, that most people on this webinar are here probably not because you have nothing better to do, but because you're genuinely interested in how can I go from my current state to something better. And whether your current state is from the poll, you don't have an MES, it's some mixture of what's on the screen. If you're on paper processes, someone missed a signature and you have to wait till next shift tomorrow to go get that signature, and now your product's late. Those types of issues that have real business impact are what we want to try to explain a way of you can address with composable solutions. So hopefully that is resonating with people.
Yeah. And so again, from kind of, that was a lot of our perspective, but just to validate kind of what the market is also kind of shifting towards in terms of like the disruption of MES or manufacturing solutions for advanced manufacturing, is that, there is a fundamental shift taking place in the MES market driven by evolving new technologies that challenge the MES status quo and driven by vendors with the agility and talent to accelerate the adoption of those technologies. So that's like, again, outside perspective, as well as kind of when we come back to what we believe is like this composable approach, again, outside perspective is being that like by next year, essentially, is that at least 25% of manufacturing operations will use composable technology architecture. That's up from 2% just in 2022, from 2 years ago. Like that's a significant percentage point increase in a fundamental shift in the way that technology is being brought to manufacturing. And so we're excited to be a part of it, but like we also see the benefits of like, obviously we see that customers are doing this, but we also see like the tangible business impact of when customers go down this route as a strategy for advanced manufacturing that accelerates adoption. And Jess will talk about this extensively, but like you see this acceleration and transformation of their traditional application into composable applications, and it helps future-proof and set the foundation for your business operations for years to come. And again, just last one before we get into some other things is in general, I guess from Gartner, in general, it's fair to assume that the longer an MES system, and it's kind of redundant, like a PIN number, the MES system has been in the market, the more effort that is needed to fundamentally re-architect it. So basically saying like, these legacy systems were built, on 1990s assumptions, 1990 architectures. They've been updated, but like it's very difficult to go re-architect that to fit, to necessarily fit the modern needs and modern technologies. And so this is a favorite of, a favorite meme in Tulip. Say lift and shift one more time, right? So like people saying, I can take, what was built on 1990s technology, their architecture, the connections to outside systems, and like I can replicate that. I can move it to the next site, or I can adapt it to today's technology. And like, sure, you can take parts of it, and you don't have to go in one home run swing to change it. But like, there are certainly merits to lift and shift is not a viable option for this composable MES, which again Jess will dive into. But thinking about like microservices and being able to do continuous improvement and all the benefits of the cloud efficiencies in terms of like your long-term cost, and having open architecture to enable the flexibility of basically integrating like new partners, new technologies in the future, as opposed to the walled off kind of MES of yesteryear.
All right, so we're going to focus on composability, as Brian has mentioned. We're going to start off with a couple slides that go over terminology. So I'm going to start with an MES, Manufacturing Execution System. So this definition from SAP says it's a system that manages, monitors, and synchronizes the execution of real-time physical processes involved with transforming raw materials into intermediate or finished goods. All right. A lot of words, but what I like about it is that it's broad. It doesn't get into things like exactly what type of data the system is collecting or displaying, whether or not this needs to integrate with your ERP. This system should serve you, a company, a manufacturer, to manage your manufacturing. So it should be helpful to you in many ways. And building on that, starting on the left, a little bit further of a definition from the Computer Security Resource Center is that an MES bridges the gap between business and plant floor systems. So business systems, if you have an ERP or you're familiar with that concept, can be thought of as they manage sales orders, usually orders that are at the time frame of weeks. They're more related to revenue. It's really more of a business motion. And plant floor or control systems refers to more of, if you have machinery, I'm sure there's a mix of folks on here, sheet metal fab, welding, whatever, manual assembly. But if you're more on the machining side and you have automation layers, PLCs, or simply just more machinery and you have sensors on them, some of that control system data that is managed on the second to minute level. And MES bridges the gap between them, and it directly alludes to ISA 95. If you're not familiar with it, ISA is the International Society of Automation, and ISA 95 is the standard that governs integrating control systems and enterprise systems. So it's just an international standard related to systems, but the definition above directly refers to where MES sits in the ISA 95 triangle. And then the one other quote on here is that MES application should be providing feedback on process performance. So now we're getting into a more detailed perspective on MES that suggests it should be giving you, the user, specific things about your process, about traceability, genealogy of your components, if you're doing assembly or you've got sub-assemblies, raw materials going to finished materials. It's telling you more about what needs to be held within the system. So that's what an MES is, and that's what we're here to talk about, what these systems used to be like and how we can think of moving them into the future. All right, so the mold of legacy MESs. We're going to refer to more traditional systems and legacy MESs as legacy MESs. So legacy MESs would be, as Brian said, systems that have been around probably for a few decades. The standard data structures that they're built on are rigid, like they're predefined. You've got X many data structures, it's probably a relational database, and you're kind of set with that. If you can't really add too many things, change very many things. And it's an available set of functionality as well, like the logic of what you can do with it, it's predetermined. So the possible data you can capture is predetermined, and it's the same for all users throughout your process. You have what you have. Most humans who are doing manufacturing process aren't doing the same thing with the same information needs or display needs throughout the process, right? Like this is one of the fundamental complexities of manufacturing is there are so many variables, different tools, different processes. So legacy systems constrain users and the process and how quickly you can change. So what we want to focus on here is that composability is a way to change this process around capturing new data. So if you have a legacy MES, it's hard to change, as I was mentioning, which is extremely ironic given in lean and most manufacturing best practices, continuous improvement is a fundamental concept. So we encourage change constantly, and yet our systems don't support that. So composability is really a way to break down that original where we started for MES and think about systems differently. Okay, so how can we get past this? Move forward into composability. It's a system design principle. So depending on who's on the call, it might seem a little technical, but we are talking about the systems that are behind manufacturing, how you collect data, where the data is stored. So it's a design principle. And I do want to emphasize it's a design principle for the systems, but it's also a different way of thinking. And you can apply composability to businesses as well. So if you want to go Google that later, it's used in a lot of ways. We are focused today on how it applies to manufacturing systems. All right, so benefits of composability. There's three main ones we're going to talk about today: decentralization, adaptability, and flexibility. Decentralization is about allowing the people who know the operations or subject matter experts to have input to their own processes. So they create human-centric solutions, but also more user-centric solutions. You're not stuck to a drop-down that has whatever predefined options that MES company A determined in 1999. Like, you can change that if you want to. And we'll get more into the concept of democratization as well and what that means for decentralization. The second one we'll talk about is adaptability. So businesses need to adopt. If you have seen any literature on businesses and how they survive change and whatnot, they need to be able to adapt. And as Brian mentioned in the first section, the world needs to adapt to constant change. So having a system that's composable reduces the risks associated with changes because you can adapt to those changes. And you can also get much faster time to value, which is critical to most companies in general. And time to value on the manufacturing side, we mean everything from more throughput, more revenue to, hey, I can reduce an hour of labor cost every shift on this part. Great, like that has business impact. And then the last one is flexibility. So hopefully that one is sounding like it makes sense given everything else we've said about composability, that you can do things in bits and pieces and it's different. It empowers folks in your business to solve specific business problems they have effectively. All right, I'm going to switch over to focus a little bit more on decentralization. So the example that we're showing here it is a Tulip app. Brian and I work for Tulip, so I think that was announced earlier. It's a Tulip app screen. And the point we want to get across is with Tulip, you can have manufacturing, quality engineers, other roles, but people who you don't need an IT background, you don't need a coding background. Like I came from manufacturing, I've never worked for an IT company, but these types of people can build apps because they know what data they need. And if they do a process change, they can change the apps as needed. It's analogous to having a quality engineer own an SOP or a process engineer own the planning or work instructions for their process. The work instructions and the planning or the quality plan are now in Tulip. So you can do that, but you can make changes much faster here as well with getting frontline feedback very quickly, getting stuff out to the shop floor, and then doing continuous improvement on that. I do want to point out that in the head of the slide, it says while maintaining governance. So this doesn't suggest just because you've democratized a solution like this, that IT or a central team has no system oversight and everybody is just building whatever they want whenever they want. That is not at all what needs to happen with a composable solution. There's plenty of functionality to do approval workflows, to constrain different types of user access. We can do a whole other session on governance of composable systems, but rest assured, it is a thing that many people have thought through and done. So decentralization and democratization are not at all exclusive to having a form of governance. Going to move on to adaptability. So this slide might look like an eye chart if you have no idea what we're talking about. We start on the left-hand side with monolithic approach. The monolithic approach refers to the legacy MESs, which is, I mentioned, you predefine data structures, predefined logic. You can configure it. You're probably paying a vendor to configure it, frankly. And then you have to plan a go live. It probably takes 12, 18, more than that months to get this legacy MES set up. And you also better hope your process engineers don't change anything in that time frame, because then you're going to have to go back and try to change that, and who knows how long it'll take. And go live is very high risk in these situations because you essentially have to cut over. You have to stop your existing system, start the new system, and hope nothing goes wrong because the whole plant is on it. The difference between this and the composable approach on the right is that composable solutions can be deployed on the order of weeks. Now, some caveats on size of scope and whatnot, but it's done in an agile fashion so that you can identify specific business problems, go solve them quickly, get something live. And an example of, we've actually done this with some customers where if you get a simple app is a Tulip term, but if you get a simple app on the floor in, say, the first couple of weeks and it saves your inspection team 10 minutes apart, sure, V2 of that app could maybe save 10 minutes apart, or sorry, a half an hour for every part. But why wait for V2 if you could have had a month of the 10 minutes apart savings? And so that's what we want to encourage when we say time to value and how quickly you can have business impact. So the little blocks on there are meant to explain you can have different specific user requirements or business problems met independently of each other. So as a need arises and as your resources have availability, you can go prioritize solving specific business problems and then iterate on them and improve on the solution constantly.
I think a key point on the right too is that you're able to solve very quickly for knowns. You can prioritize when we have a methodology for prioritize, low hanging fruit. You can go tackle things very quickly and iterate. Jessica mentioned on the order of weeks. I've been to clients that, do a workshop and something's deployed that day and they're getting data, they're getting value very quickly, or they're using an app from the Tulip library and they're importing it and started using it immediately. That's the level of things, and you're iterating, continuous improvement, right? Core thing. But you're also able to start, you're also able to know that you can change things for the unknowns, the things that you haven't thought of or the things that might change in your operations. That's so powerful with this concept.
That's a really good point. I'm thinking about future proofing because especially in today's environment where technology, when I say technology, I'm now referring to everything, the smartphones, all of that, AI. The rate of technology change is faster than we've ever seen. So how can you try to future proof your business and your operations? It's through tools like this that allow you to change, not that lock you into certain logic.
Exactly.
Well, all right, thanks, Brian. So now we're talking about flexibility, which was the last word that I had a few slides ago. So a flexible platform approach avoids the sprawl of multiple point solutions. What we're referring to is MESs solve problems, but they often have gaps. And that speaks directly to the poll results for those of you who do have MESs. And you said it works okay, but it doesn't always give me the data I need. I might have some inefficiencies. It's probably hard to change. Because there are gaps, some companies take the approach of, let me fill those gaps with point solutions, meaning different softwares for specific things that you have a gap in. But what this results in is a bunch of different softwares you have to manage. It's administrative work. You can keep your procurement team busy with negotiating 12 contracts a year, but that's probably not the most efficient way to run your business. And the way composability provides value is you can solve these through a platform-based approach. So with a platform, so we've said already, you don't have to rip and replace, you don't have to lift and shift anything, but you can start moving toward addressing gaps in any existing systems with this platform approach through a single solution that is the platform, and not have to manage all these individual systems that different logic, different setups, try to integrate data in between them. I can't imagine the sort of mess you might end up in with trying to have 10 plus different systems that you're trying to integrate to each other. A little bit more on this flexibility concept. We just talked about the right-hand side of the last slide. You have a single platform with multiple solutions. If those little dots represent solutions, and it also goes back to we've talked about solving specific business problems. So like one little dot might be a final inspection guide to collect data and like which inspector is inspecting which part on which day with which defects and taking pictures of the defects. And maybe another dot is addressing, incoming receiving and making sure that the parts from incoming receiving get to quality, and quality knows when critical parts are there and they can see that. Like you can solve different business problems and then connect data and solutions as needed. That approach to get there, it doesn't require moving over immediately. So you can start out with whatever systems or no systems you have today. You can start building solutions within the composable platform. And if you have systems, integrate with them, right? So you don't need to go cut over. You don't have to stop things with your current MES. You can start building that over and then transition over time. And as new technology comes up, you can start integrating that technology and changing your solutions as needed. And that's what we were referring to last few slides ago on future-proofing as well. You'll be more ready to adapt to new technology. I think that's the last slide in this section. What we're going to walk through next, and Brian's going to take you through, is an example of composability in practice. So what this actually looks like with a real customer taking an approach like this.
Yeah, thanks, Jessica. I think I'll just add one more thing here is this concept of composability scales within the four walls of a single manufacturing facility, but then it also scales enterprise-wide. So those individual blue dots there can be within a single site, but then you can also use those blue dots for other sites or the concepts, the best practices. This platform approach allows you to scale across your enterprise globally if that's your situation. Or we have some customers that are super successful that are a single shop or 3 shops, whatever, and it still works very, very well. So I think it's a great segue into let's go talk about composability in practice. So we're going to talk about an example from Stanley Black Decker. Stanley Black Decker is, selected Tulip and is implementing Tulip across, manufacturing sites globally. Just to think about kind of how they've self-structured themselves. I think Jessica mentioned kind of this Center of Excellence or adoption program. So really the COE is there to standardize and share best practices and scale effectively. And kind of the way that they've done this is this team supports other teams across sites. And we'll get into kind of how they tactically do this. But there's a director of digital transformation, and then there's program manager. There's a series of application engineers, typically from manufacturing backgrounds, right? That we're an advanced manufacturing engineer, and some of them had direct experience with Tulip, and then they became on this team. Or some of them didn't know anything about Tulip, but they know manufacturing, and they were able to think in that they're able to think about how does this type of technology benefit manufacturing, and so they have this center of excellence that kind of defines these standards, the best practices, and shares those across their global network of sites, and across many business units too. I think it's another interesting thing around a company like Stanley Black Decker. It spans multiple business units, and so they've kind of taken this multi-pronged approach where they have standard applications, which they develop and deploy and they maintain and they make them available for anybody to kind of say, hey, I need a quality application, or I need a quality SPC application. I need 5S, right? There's a global standard for that. And any number of sites can kind of go pluck that from the SBD library and then adapt it if they want to, or just keep using those applications. And again, immediate business value. There's also, of course, the citizen development. So when we said decentralization or democratization, again, this tool is available to anybody within their network. And so there have been what we call citizen developers. And again, this isn't unique to SBD. This is what we see at almost all of our customers, that people start saying, okay, I have this tool at my disposal. I have problems I need to go solve. And this platform enables, citizen developers to go start building solutions. And again, that digital transformation team helps, support and guide and kind of provide the left and right guardrails for what, a citizen developer can and can't do from a governance perspective, IT security, those types of things. But by and large, citizen developers are able to go start solving their own problems, because who else is best positioned to do that? And we'll show a very detailed example of what that looks like in a couple slides. And there's enterprise solutions. So again, they've characterized, SBD's characterized this as, systematic solutions for digitizing manual processes. So things like behavior-based safety, returns processing was a huge game changer for them. All the returns they get from the stores, this has been that has been something enterprise-wide that they, isn't an MES, but again, it's a really unique solution that can all fit under one platform of Tulip. And when they started, they didn't know that returns processing was a pain point for them, but they were able to say, okay, I got this tool now, so I'm going to be able to do this, get a lot of money saved from the way that they're able to do that and solve and spread this solution. And there's key site focuses. So of course, in any business, hey, the business says, hey, we need to go focus on these sites. This is where we think there's a lot of efficiency to be gained, a lot of business value to be extracted. And so this digital transformation team can help support, these sites in terms of kind of going in, scoping, understanding where the pain points are, and then helping the sites, build up citizen developers at the sites, but also help deliver solutions within the best practices. So things like heat treat logs, die tracking, very unique things that a site that does, that makes blades is very different than a site that makes the hammers versus power tools. Again, lots of different manufacturing processes. It's not one size fits all. You got to be pretty unique. Just an example, again, another example of kind of how they kind of do this. They have digital transformation team led apps and citizen developer led apps. Again, this is non-exhaustive. There are many, many, many more solutions, but again, just kind of showing what those look like. Things like 5S, digital and-on, digital tier, digital boards. Am I winning or losing the shift? Right, hour by hour, physical inventory, things that a lot of sites all have needs for. That this team can say, hey, great, go use this tool. Make changes if you need to, but here's the great starting point. And there's also this citizen development led ads, or led apps, this process for quality recording SPC both in UK and the Czech Republic, and then assembly hour by hour that they wanted to use in a site in Michigan. Again, that concept is not unique to Michigan, but they had certain views they wanted to do, so they adapted what they needed to in terms of Tulip, in terms of an application in Tulip. So kind of zooming in here, we're going to show you some pretty a very detailed example of composability in practice at one of their sites. And this site is at a site in Mexico called Hermosillo. It's around 400 operators, and they make outdoor power tools. So if you think of your DeWalt or your Craftsman, battery powered leaf blowers, hedge trimmers, weed whackers, and you're in North America, it's likely coming from here. And they also make battery packs. So think about you get your DeWalt battery pack along with your leaf blower, the batteries inside of that are assembled together, come from this facility. So this entire site runs on Tulip, full stop. Every single person you see on that right-hand screen is basically interacting with a Tulip application in real time or at some point in their day. And in this picture, there's each one of those screens is a Tulip app. You can notice individual screens in front of operators. They have, the big tier boards and the hour by hour boards, which we'll explain more detail. But again, everything here also included here, IoT devices, scales, barcode scanners, there's a lot of stuff going on here that you may not be seeing, but it's great. Like, so 95% of those employees touch Tulip daily. And what they've really built is an ecosystem of applications and dashboards that, enable management to see production, not only management, but also the operators to see production in real time and get insights in real time to how they're operating. And then they also have, will show digital tier dashboards. So they understand the real time progress of manufacturing, but also of problems. And they also have instilled a system of accountability, which we'll share. And by the way, they built almost all of this in about 3 months. It was pretty awesome to see. They built a lot of this in 3 months, and they've iterated and continue to iterate and built more applications, more ideas as things have surfaced. And again, just to kind of show like how successful this has been, and you can't share like the direct numbers, but I'm sure you could kind of directionally understand like if this, the bottom right there is like the site's scrap goal was 5%. The stretch goal was 3%. Like they're consistently operating at 0.2% scrap. Like that's scrap alone. You can kind of think about like the other metrics that might matter, but like that's the level of performance that they're able to operate at. And it's pretty awesome to see. In terms of the culture of system development, again, that's that decentralization, that democratization, that system development persona. This all started really with a core nucleus of app builders, and really one gentleman who's an extremely bright and talented person. He's an engineer. He was empowered to basically build these applications with our platform. But again, it's the composable architecture. Understand, I'm going to have this tool at my disposal to start solving problems. They have. Over time they've built up this platform, their practice of Tulip. They didn't start here, but they're at 50% of salaried staff are trained in Tulip. And so it's not the point that 50% of people are going to build applications. It's that they understand the power of a composable platform, of this composable solution, and that what problems they can that they can now start tackling. And so it's like a mindset shift of, I know that with this tool, I can go solve these problems. And then they have app builders that can go tackle it. And so just in terms of the culture, like they hold app building competitions every 6 months for like citizen developers. They're all like, literally they're excited to go showcase like their best ideas. And like the plant manager, there's like a system of recognition in terms of like people that win. And there's also training programs with citizen development committee. There's an idea portal for like a Kaizen perspective of like, submitting ideas. Like it's just a cultural mindset shift, which is enabled by this platform. Just imagine your legacy system. It's like, good luck changing anything. Good luck putting an IT ticket in and hope that gets read by someone in 6 months and you change that drop-down menu. Like that happens in real time, like that day. Like just think about that, like that continuous improvement mindset that gets enabled by something like this. Again, I mentioned that ecosystem of applications. Again, this is kind of like in the framework of they started off in one area, but then quickly scaled to this more or less an MES, right? So they have guided assembly and work instructions, which are available to operators. So what really struck me here is like when I go into most manufacturing facilities, like on the line, there's the clear sleeve with like the work instructions like printed out, like stuck in there, and nobody's looked at it. Nobody ever looks at it, and it might be out of date. And if there's a changeover, you got to print everything out, rip it out, put new ones in. That's great. Or that's not great, but like what they've done is like they basically say like, hey, these work instructions are all digital. The operator has access to them in real time if they need them. Again, they're making leaf blowers. Like the operator's not doing a guided, like necessarily guided assembly. Like they just need access to the work instructions. So it's like and by the way, like whenever they're doing a changeover, like these work instructions automatically change to what the latest version is, what the SKU is. Like it's incredible. They also have visual management and production tracking. So am I winning or losing the shift? How am I doing? What am I actually supposed to be making? They're getting data from SAP. So they're able to understand like the work orders, the quantities, the progress. They also have scrap and rework stations. So, again, they've adapted these over time to understand and be agile to like learnings that they've had in their facility. Real-time alerting and andon. So, with a platform like Tulip, you can send out emails, text messages, you can integrate with Slack and Teams. They chose Slack. You can see on the right that, somebody's wearing an Apple Watch, getting a notification real time of a maintenance event. And then also this receiving application. I'll touch on it very quickly. I think it speaks to the power of, hey, nobody would ever think that like a receiving application would be integral to a manufacturing, system, integral to manufacturing. But the problem statement was every time they get a truckload of inventory of material, they have X number of hours before it needs to be unloaded and back out to the company. They used to be doing this on whiteboard. They were getting penalized for going over the time, like lots of money. And all the company would also say like, hey, by the way, you returned it to us dirty, it's damaged, and add additional fines onto that. They started tracking this stuff in Tulip, basically doing a FIFO method, like a board, being able to send alerts to people if you're running up to a certain amount of time, having a single overrun. They're also taking pictures of the inside of trucks when they receive it, when they send it back. So when a company says, hey, by the way, you sent it to us dirty or damaged, and they say like, hey, no, we didn't. Here's the picture to prove it. Like, so just a lot of money is being saved. And they're also able to scale this across other sites. This great idea started at Hermosillo. Sites around the network are saying, hey, we can use this too, and kind of scale that concept.
Right. One comment on the last slide. I do want to point out for folks that this is, so if remember a few slides ago where we had a composable system is a bunch of these little dots, like these are all examples of the little dots. This is not how you start. If this is feeling a little bit intimidating, because this is amazing stuff. It's really cool. It's across the whole site. They didn't start here, right? We've been working with them for quite a while, and they've had Tulip also, like they really have done this on their own, but they started smaller, and Tulip always recommends starting smaller and piloting. So just keep that in mind if you are looking at a company who has really digitally transformed and put a ton of resources into this over a good amount of time, but this wasn't day one for them.
Yeah, and again, it's a journey, and again, it's those building blocks of the knowns, the unknowns, and eventually getting to scale. And sorry if this is coming across as intimidating, but like it gets really valuable stuff, and it's exciting. All of these applications are collecting data in real time out in the shop floor. And what they've also done is built these digital tier boards. So depending on the level of management meeting, either tier 2 or tier 3 meetings, they're coalescing all of this data and making real decisions based on information, historical and real time. And they're bringing in different sources of data as well. So it's like, quality, the actual production, safety, 5S. They're also bringing in financial metrics as well to understand how's the plant actually operating. And then I think what's really important to bring in here is this idea of accountability within this. Like when I was there, the plant manager, said to me like, hey, manufacturing's messy. We're going to have problems. And it's not, we're going to have problems. It's not about pointing fingers, it's about solving them. And so they used to have these like this stick it post-it note system of hey, we have a problem. Who's doing it? Like going to different lanes and saying, hey, we've made progress or not. They've actually implemented this where it's automatic, where they, during these meetings, they'll say, hey, we have a problem. And then if at subsequent meetings there's not enough progress, they just put a red X. And if you get to 3 red X's and it gets escalated up to a tier 3 status where like the plant manager then becomes informed. And it's like, it's very apparent that like this drives accountability within the team to solve problems and really elevate their standards for each other. Again, it's not advocating that every company has to do this, but like this is like the tool. This is like the ability, like this is an outcome of like the tool that they have to like help drive better outcomes for themselves and like control their own destiny. Again, just an example of what this looks like in practice. Their tier 2 and tier 3 meetings, briefing, like the pre-shift meetings, like what are we doing today and how are we going to how are we going to do better? Kind of the last thing here is just highlighting what are some of the citizen developer more like type of applications at this facility. What I showed previously was more or less like that center, that nucleus, right, of like that one engineer kind of started this and like built kind of like a community of practice around him. Now there's like lots of citizen developers that all know that they can go build applications and solve problems. And so some of those, just to highlight, are like 6S, environmental monitoring. So again, I mentioned the battery package building. Like that has to be done in a climate controlled environment based on humidity and temperature. And so they're able to monitor that to understand in real time if they're going out of specification, but also if there's quality issues and quality escapes, they can go back and say, hey, was it based on environmental conditions? Again, it's really cool. They also, MRO was not, kind of in a very legacy system. They built it up in Tulip. It's way more flexible, can share information, connect to other systems, spare parts, overtime request facilities. They even had, as something as simple as something as silly as for their cafeteria, are you happy, feedback for that? Just like you're able to extend, to other parts of your operations. So this was, hopefully a pretty enlightening example of what composability looks like at a company that's doing it very, very well. And I think with that, Jess, I'll turn it back over to you.
Yeah, thanks. So again, this is an example of composability having been executed and done. So we'd like to think of like more of an inspirational vision of what a lot of our people we work with can get to. We've done initial deployments with hundreds of customers, and you start small and you iterate, and it takes time, but it's great to see companies who have shown that the methodology and some of the concepts truly work if you implement them. Then to move on to summarize with a couple trends, and then we'll wrap up and get to Q&A. So breaking the mold, strategies for manufacturing excellence, a couple things that we've talked about today. One of them is that systems should support the business strategies you have and support value creation. That was our whole spiel on legacy MESs who sit there, they've done good work for a long time, but you can get time to value much faster with composable solutions, and you should be able to pivot your business strategy and have your solutions serve that. The second one is embracing approaches that support your organization. So this gets into when we're talking about decentralization and democratization, allowing businesses and individual people who know the problem to solve the problems that they want to solve and prioritize them when they need to solve them. Third one here is a focus on human centricity. I also mentioned user centricity as far as solving specific business problems, but also human centricity refers to doing it in a way that benefits the actual people using the solution, not building a solution just because it is what the system should be doing from like more of an IT architecture standpoint. And the fourth one is thinking about how to future-proof your technology architecture needs. We already talked about this quite a bit, is everything is changing. Technology is changing. Your business and your processes and your products are probably also going to change. They probably will have to as the world changes. How can you try to set up your business to address those things in an efficient manner? So composability is a concept we hope you have a better understanding of now. And the last thing before Q&A is we did want to mention there is an upcoming webinar with Tico Tractors. For those of you who are smaller companies, so understanding Stanley Black Decker is an enormous company, and a lot of folks out there are probably saying, I'm not Stanley Black Decker. We are much smaller. Tico is a great, great story. I encourage you to listen to them. They started out with Tulip. I think they had no MES when they started. They've also been with Tulip a couple years, and they truly started like one app, two apps, very small, and slowly over time started building in more functionality. Mike is great. He's been a Tulip customer for years, and he's been promoted quite a few times, I think, since he initially did the Tulip deployment. So we're excited for that, and I think we are going to hand over for questions now.
Thank you very much. We will now begin our Q&A session. And as we have some questions already submitted, we're going to jump right into it. So what is composable technology architecture? Can you explain that again for us?
Yeah, maybe I'll take that one. So what we were trying to draw the difference is in traditional systems, there's a certain level of architecture that's predefined, and it's associated with whatever logic the system has, right? So that's why sometimes you can't add new logic. And this is also true for some ERPs. You can't just add new logic because it might require a new column of data. They can't just add that to their database. It would require coding the entire product differently. The difference with composable architecture is that you can design it based on the user requirements and needs, and you can change it if needed. So if you change your process and now need to add a couple more columns, you're collecting different types of data, or change a column or remove a column. And sorry, when I say column, I'm saying things like, say you have a work order and you're tracking the name of the person, what time they did it, maybe some critical to quality dimensions they're recording, and quality has changed what they want to record about that work order. You can change those things. So the architecture also goes with those. I go back to the slide with the dots. You can architect the system and the data behind it related to what business problems you're solving, and it can change with you. Hopefully that makes sense. This is also, if you're a systems person, this also could be like a 3-hour conversation. So I'm going to stop there.
Okay, then we'll get to the next one. Next question, how is the data, and they specify bombs, routing, work instructions, etc., governed and controlled?
That's a good question. So we're making a couple assumptions here that things like bombs and routing are all held in, say, this composable solution called Tulip. I say that because in some companies, an ERP might be the system of record for their bomb, in which case a system like Tulip might be pulling in the bomb from the ERP. But in Tulip in general, I think the question is, how is data controlled? This also, you could apply that to how are the apps and the logic controlled? So there's different permissions. I mean, there's a couple things in here. There's different permission levels in Tulip. So not every person can have the ability to adjust a table structure that has the BOM or the whatever data. You have standard routing. You can lock it in. You can adjust who can do what from an editing standpoint. And then if there is a change to the app logic that refers to that table structure, so say, and it's standard routing, you need to change the routing. Some people are allowed to make that change. If a change is made, it only is going to impact the app using the data structure for routing if someone also appropriately adjusts the logic. And there's controls around how you publish, getting approvals before you publish an app. So there's some, it's pretty normal change management and governance structure around making content changes in Tulip applications.
So next question, this is a multi-part. How does the composable approach work when replacing an existing legacy MES? Do you replace core functions of the MES one at a time? And how does that help with cutover?
Yeah. So I'll start answering that one as well. Jump in if you want. So with cutover and what we talked about reducing risk for that, it does depend what your MES does today. So depending on if there are gaps, certainly you can fill the gaps without creating any cutover need from your existing MES. If you have an MES and you actually are cutting over functionality-wise to a composable solution, it might be better to think about it as doing it in pieces, like area A, like your welding area, or like line A or product A is going to move first. So maybe the rest of the plant is still on your old MES, but you've replaced the functionality and probably augmented it or added onto it with the composable solution. And you're going to implement in this area first. And then you can go area by area and also continue adding on functionality. So that reduces some of the concept of a full cutover for the entire plant. For core functionality, you also could replace it from the MES standpoint of, say your MES is tracking work orders, work order start, stop, complete, here's the scrap quantity, whatever it is. If you wanted to start replacing specific functionality, like we're going to do scrap and rework in Tulip, but we're still going to track work order starting complete in your MES, you can do it and run Tulip in parallel to your existing MES. At this point, we'd probably be talking about very detailed trade-offs, like your operators will have both systems up, what the pros and cons are of that and all that stuff. But there's a couple ways that you can go about this depending on your current state.
Yeah, and we've seen, I think, most situations at this point with customers and can provide guidance, best practices, and the trade-offs that Jessica was mentioning. So, like, again, whether or not that direct question applies to everybody, or I know it doesn't, because it won't, but we've seen the full spectrum and can help provide
all the combinations of no systems, old systems, new systems.
Yeah.
Okay, next question. How is the data that is required by the ERP upon completion of a work order returned to the ERP?
So Tulip can integrate with other systems. There's two standard ways that we integrate with systems. It's either REST APIs or SQL. So assuming a lot of ERPs can use REST APIs, usually there's an IT person involved at this point to configure the API on the ERP end, but you can transact data, you can push pull both ways, and that's just pretty standard system integration work.
Yep.
What kind of timeline would we be looking at for full implementation?
I'm gonna give the worst answer here, but it probably depends. In terms of the scope and scale. Again, for highly motivated customers that have citizen developers that want that learn Tulip, and there's I'm working with a customer right now that has basically built a full MES from scratch in I think 8 working weeks, including the holidays. Again, it's an advanced advanced robotics company. It's not the biggest facility in the world, right? But it is a meaningful production facility, and they have built that. But it can be the order of weeks. But again, if it's multiple lines, massive production, it can take longer. But But the point being is that the implementation isn't a light switch. It doesn't have to be a light switch, and it probably shouldn't be. It's those building blocks of I start here, I get data, I'm collecting, I'm getting value, and you're incrementally going up and tackling use cases on a roadmap that is defined but also flexible, right? So it's again going back to the knowns and unknowns. Jessica, do you agree?
I know we're at time. I just also wanted to add, or devil's advocate here. Are you ever really done? There's probably a set of functionality that you were set out to implement that. And as Brian says, it depends because this can range, but we want to enable continuous improvement. So, full deployment, fine. You scope it, you check that box, that's full. But in theory, you should always be iterating and continuously improving. And so you're never done from the standpoint of like lean continuous improvement and transformation. There's not a finite end state to that.
Yep.
We have time for one more. Okay. Who are the citizen developers you referred to in your presentation?
I'll take this. It's quality engineers, advanced manufacturing engineers, continuous improvement engineers, people that know the processes, that have vested interest and help design the processes and can see the inefficiencies. Those people typically know, or the if then when logic of kind of a composable solution like Tulip of again, no code. Those are the people that get if then when, from their engineering background. They don't need to know Python. They don't need to know Java that an traditional IT background would know. It's the engineers on the shop floor.
Okay.
And they're typically excited to have something like this.
Cool. All right. That is all the time we have for today. I'd like to thank Jessica Yen and Brian McGarvey and our sponsor Tulip for today's presentation. On behalf of Industry Week and Smart Industry, we hope you have a productive remainder of the day. Thank you very much for joining us.